Welcome to another unit in this workbook, Statistics. This time I'm going to talk about how to compare means or how to test means versus other given values. If we talk about this topic, then we can roughly differentiate between two tests. The first one being the so-called Gauss test, which is built on the normal distribution. This is always used if we either have enough observations or, that's the most common thing how to determine if we use this test, we already know something about the underlying variance or standard deviation. If we do not have this information, or we have simply too few observations, then we're going to use the t-test, which in market research and other practical contexts is oftentimes the only test being used as well. Well, what's the general idea underlying all of this? Well, we're going to test whether the value we want to compare our mean with is actually close enough to the mean so that we can assume any difference is just due to random fluctuations, or whether it's too far away so we could say, yeah, there is a difference and it's a significant difference from the mean we just calculated. For this, well, as I said, we're talking about the Gauss test first. We assume that our variable is normally distributed. We have a mean, we have a standard deviation and a variance, and we know the variance. Or if we do not have any information on the distribution, we need to have a sample size which is large enough. Here it says 30 observations at least. I would always personally go with at least 50 observations. If we have a two-sided test, then we are simply going to compare whether the mean we have is equal or unequal with regard to the test value. We could do this as a one-sided test as well. I'm not going to talk in a lot of detail in this unit here, but you could read this up in a book. Then we have smaller here, larger equal here, or larger here, smaller equal here. In this case, also the test statistic will look slightly different, or rather the comparison of test statistic and reference statistic. Well, the test statistic in this case, and the other ones, is simply arithmetic mean, so the approximation for the actual mean we just calculated, minus the test value, divided by the given standard deviation, multiplied with the square root of the number of observations. So it's the difference, it's the rescaled difference, and it's dependent on how many observations I have. Well, once we have this test statistic, we need to have a reference statistic as well. This reference statistic is pretty easy because it's simply z1 minus 1/2 alpha. 1/2 alpha, since it's a two-sided test. If again you were using a one-sided test, you would use 1 minus alpha, or depending on the type of test, alpha. Where do I find this reference statistic? This reference statistic can be looked up in this table. And it's usually tables like this where you get a certain percentile, which is just the 1 minus alpha or 1 minus 1/2 alpha. So it's the value you have down here. You look this up and then you find the corresponding value, the corresponding quantile for the Z distribution, which is nothing else than the normal distribution. So whenever we have the values with Z here, this means we're using the normal distribution. Well, as I said, that's relatively straightforward. Getting the test statistic, getting the reference statistic, and as with all tests, if the test statistic is larger than reference statistic, then we can reject H0. H1 holds. So in this case, we can say that there is a significant difference between mean and testing value. Whereas if the test statistic is smaller than a reference statistic, we have to assume that there are no significant differences, and any differences we see are just due to random fluctuations. Well, so much for the Z-test or the Gauss test. Let's now turn to the t-test, With the t-test, we also have normally distributed data, but our variance or standard deviation is unknown. We have to calculate this first. The hypotheses, however, look pretty similar to what we already had before. And also the test statistic looks quite familiar. The only difference being, well, we do not know the standard deviation. So we first have to calculate the standard deviation on our own. So we use the sample standard deviation. That's why I have a small s here. That's the standard deviation which we calculated, the sample or corrected standard deviation. The reference statistic, as compared to the previous one, is now a t-statistic. A t-statistic with n-1 degrees of freedom, n being the number of observations, and 1 minus 1/2 alpha. Again, because it's a two-sided test. Two-sided test means the value we have could be smaller or larger than the mean. One-sided test, we just assume it's on one side of the mean. As I said, the first part is the degrees of freedom. The second part depends on the margin of error. We're going to look this value up again in the table for the t-distribution. The table for the t-distribution, we have as a column value what we get for the margin of error, so the 0.95, 0.99 or something, and the degrees of freedom are situated in the rows. So first off, find the correct column, then find the correct row, and there you find the respective value for the t-statistic. The test itself, similar to the Gauss test, if the test statistic is larger, we can reject H0. H1 is the one which holds, so there is a difference between mean and test value. If the test statistic is smaller than the reference one, they're both identical. All differences are just due to random fluctuations. Well, that's the main idea behind the t-test as such, with an unknown sample variance. We can, however, use the t-test also to compare two means, or rather the means from two samples, because before we just compared the mean with a given test value. We could, however, say, well, we have two samples, both of them normally distributed with unknown variances, and we want to know whether this means of the two samples actually are the same, well, same except for random fluctuations, or they are significantly different. Which also leads us to our hypotheses. Again, for a two-sided test, the means are the same, H0, the means are significantly different, H1. If we want to conduct such a two-sample t-test, we have to do much more with regard to the test statistic. And that's what we can see here. First off, we need to calculate some kind of joint variance. And this is, we take the sample variance of the first sample variance of the second sample, and then we weigh them by the number of observations in each sample. And we divide this by the overall number of observations minus 2. So it's like a weighted average of the standard deviations of the two samples. Thereof, we take the square root to get this large S here, so our replacement standard deviation. Instead of subtracting from the average or from the arithmetic mean our test value, we're going to subtract from one of the arithmetic means the other one, and we're going to divide this by the square root of the number of observations in both samples divided by number of observations first sample times number of observations second sample. This is more or less the replacement to when in the previous slide we multiplied this with the square root of the number of observations. Well, once we have calculated this test statistic, we also need a reference statistic. Here the reference statistic is overall number of observations, so observations in the first sample plus observations in the second sample minus 2, because we have two samples. Previously, we only had, in the normal t-test before, we only had one sample. That's why we only subtracted 1. Here we have 2 samples, so we subtract 2. And we have 1 minus 1 half alpha. That's exactly the same as before. So we look this value up in our table for the t-distribution, exactly the same way as described in the slide before, and test it. If the test statistic is larger, we have H1 which holds. If it's smaller, H0 holds. There's no difference in means. Well, that's then everything there is I wanted to mention with regard to comparing means, with regard to testing means versus some test values. So I hope you enjoyed this session. I say goodbye and see you next time.